Hey everyone, welcome back to Coroutine Lab. Today we're diving into something that's small in syntax but huge in impact, Kotlin extension functions. Extension functions make your code cleaner, more readable, and easier to test, whether it's simplifying null checks or making your domain logic more expressive. Let's explore how these tiny functions can lead to big readability wins and help you level up your Kotlin skills. Here are a few string extension functions to make your code more expressive and elegant. Capitalize first capitalizes just the first character of a string, perfect for tidying up names or titles without affecting the rest of the sentence. To title case splits a string by spaces and applies capitalize first to each word. For example, hello world becomes hello world, ideal for headings or UI labels. Remove white spaces strips out all white space characters, including spaces, tabs, and new lines. Handy when you need clean, compact strings for validation or comparison. Remove special chars. Cleans the string by retaining only letters, numbers, and spaces. Great for sanitizing inputs like usernames or search terms. Word count. Counts the number of actual words in a string, ignoring extra spaces. Useful for quick analytics or simple validations like comment length limits. Total chars. Returns the total number of characters, including spaces and symbols. Think of it as your raw character count. Mask, a standout utility that replaces characters between a given start and end index with asterisks. It's perfect for hiding sensitive information like email addresses, phone numbers, or credit card numbers. Now let's take it a step further with some smart validations. First, we define a type alias called validate, a neat way to represent any function that takes a string and returns a Boolean. Then we create two validators. Verify email uses a regex pattern to check if the string resembles a valid email address. Verify phone number checks for a valid phone number format, allowing optional plus signs, spaces, or brackets. These validators are defined as lambda expressions using the validate type alias and are then turned into extension functions, isEmail and isPhoneNumber. With these reusable extensions, your string handling becomes not only cleaner and more testable, but also much more expressive. You've just seen how string extensions can make your code cleaner and smarter. Now it's time to level up your Kotlin game even further with number extensions. Number extensions in Kotlin let you wrap powerful number operations inside clean, reusable methods like magic, but readable and safe. Before diving into the number-specific extensions, let's introduce one powerful utility you'll want in your Kotlin toolbox, a safe transformation extension for nullable types. Here's how it works. It's a generic extension for any nullable type T. If the value is not null, it returns the value. If it's null, it returns a default value that you provide. This gives you a clean, safe way to handle nulls without repetitive if-else blocks. Now let's look at some handy number extensions. Or 0 for int, float, and double. These return 0, 0f, or zero point 0 if the number is null. They're perfect for avoiding crashes and ensuring safe defaults during calculations. Percentage extension. This extension calculates what percentage an integer is of another. If the total is 0, it safely returns 0f using takeif to prevent divide by 0 errors. In range or. Checks if a number falls within a given range. If it does, it returns the number. Otherwise, it returns a fallback value. This is especially useful in form validations or applying limits. Format decimal formats a number to a specific number of decimal places. It defaults to 2 decimal places, but you can customize it as needed. This is your go-to utility for currency formatting, statistical precision, or polished UI displays. Time to take your Kotlin clean code game into the world of dates and time. Let's explore some beautifully crafted extension functions that make working with local date and local date time effortless and elegant. To-formatted string. This formats any local date using a pattern you provide, or defaults to the commonly used DDMMYYY format. No more repeating date-time formatter logic everywhere. Just plug and print, simple and reusable, to relative time for local date time. This is incredibly handy for UIs and chat timestamps. It calculates how far a given time is from the current moment and returns a user-friendly string like just now, 5 minutes ago, 3 hours ago, or 2 days ago. Human-friendly for local date. This function checks if the date is today, yesterday, tomorrow, or else it returns a nicely formatted DDMMMYYYY string. This is perfect for things like notifications, calendar views, or activity logs where context matters. Get day of month suffix for int converts a day number into its correct suffix form, 1 to first, 2 to second, 3 to third, and so on. It even handles special cases like 11, 12, and 13 correctly by returning tx. Pair this with day numbers to display clean and human-readable labels. These small yet powerful extensions bring polish, readability, and clarity to your app's time-related logic. So the next time you're dealing with dates or time, make it friendly, make it clean. Let's take a common pattern in code, if-else chains, and see how we can turn it into something cleaner and more idiomatic in Kotlin. The code on the left works just fine to get a temperature description based on the current temperature, but it's verbose, and the repeated structure makes the logic harder to scan and maintain. The version on the right, it's much cleaner. No return keywords, no curly braces, reads almost like a rulebook. This small change doesn't just reduce lines of code, it boosts readability, testability, and helps future developers instantly grasp the logic. Now let's look at another classic Kotlin cleanup, refactoring from if-else to when. In this case, we're calculating the area based on the type of shape passed in. Sure, the code on the left is functional, but it contains repetitive type checks and branching logic. As the number of shape types grows, this style becomes harder to manage and scale. On the right, the Kotlin code is clean and expressive, concise and elegant, eliminates redundant return statements, reads like a decision table, type safe thanks to smart casting. Now let's take clean Kotlin even further by moving logic where it naturally belongs into extension functions. By creating an extension function on the shape class, we dramatically improve the design. This is Kotlin done right, avoids unnecessary casting, scopes logic close to the data it works on, type safe, maintainable, and reusable in Evan. Let's take a simple function, getting a user's display name, and clean it up the Kotlin way. The optimized version on the right is much cleaner. Instead of chaining multiple if-else or null checks, we use the Elvis operator to automatically fall back through available options like name, email, or a default value. We can take it a step further by eliminating repeated calls to user and keeping the logic tidy using the with scope function. This helps reduce noise and focuses only on what matters, choosing the right display value. But why stop there? We can make the code even cleaner by turning it into an extension function on the user class. This brings the logic closer to the data it operates on, improves readability, and makes the code more reusable. Now let's go one level deeper into clean code with a custom utility function, map_or, designed to safely transform nullable types. Here's how it works. If the object is not null, it applies the transformation using the block. If the object is null, or if the transformation returns null, it falls back to a provided default. Now let's apply this to our existing user extension function. The result reads like a sentence. If the user exists, try to use the name. If that's not available, fall back to the email. Otherwise, return unknown user. Let's clean up a real-world function that sends notifications to students, but only when the sender is an admin and the message is valid. Before, we start with traditional nested if blocks. While this works, it quickly becomes deeply nested, repetitive, and hard to follow at a glance. After, a cleaner, more functional Kotlin style transforms the code with several improvements. Take if elegantly checks whether the sender is an admin, completely removing the need for nesting. The optional let on the message safely scopes execution only when the message is non-null, replacing bulky null checks. Chained filter calls make the logic crystal clear. First, we filter out users without emails, then we filter based on type. If you're using a custom inline extension like fast for each, it can offer a performance boost over the standard for each. The result? No more mental juggling of multiple nested conditions. Here's a simple example that shows how Kotlin can clean up even the smallest pieces of logic with its smart null safety features. Nested if checks are the old school way. Now compare that to using Kotlin's let, a much cleaner solution. No nested structures or boilerplate. Both values are safely unwrapped. The logic is scoped precisely to when both values are valid. You can make it even more concise with destructuring or helper functions, depending on the context. This function accepts two nullable parameters and a lambda. It checks whether both parameters are non-null, and if so, executes the block with those parameters, returning the result. Otherwise, it returns null. This single expressive call replaces all the nested null checks with clean, focused logic. That's the power of building small, reusable utilities in Kotlin. Your code becomes cleaner, safer, and more readable everywhere you use it. We've cleaned up strings, handled numbers like a pro, and made null safety elegant. Now it's time to tackle something we use every single day: collections. Whether you're filtering data, transforming lists, or checking conditions, collections are everywhere in your app logic. But when messy if-else statements, null checks, and nested loops creep in, even the simplest operations can start to look overly complex. We start with smart defaults using functions like or empty list, or empty map, and or empty set. These use the Elvis operator, da, to return the original collection if it's non-null, or an empty collection if it's not. Let's see how this improves even basic return statements. In the first version, we call a method that might return null, store it in a variable, and then use the Elvis operator to return empty list if needed. It works, but feels a bit verbose. Now, take the optimized version using or empty list. You skip the temporary variable entirely and just return the safe, non-null list in one clean line. Let's push our collection cleanup further with the when not empty. This generic function hides the null and emptiness check behind a clean, expressive block. It only executes the lambda if the list is both non-null and not empty. Compare that to the original approach where you check list.isNull or empty every time before processing. It clutters your logic. With when not empty, you get fewer conditionals, cleaner logic, crystal clear intent. Do this only if the list has data. Accessing an item by index in a list is a common operation, but if you're not careful, it can crash your app with an index out of bounds exception. In the first version, we handle this safely by checking if the list is null or if the index is out of bounds, and return a default value in either case. It works, but the logic is cluttered. It mixes null checks with bounds validation, making the method harder to read and maintain. The optimized version simplifies this by turning the logic into a clean extension on list string. Now, you assume the list exists and handle only the bounds check inside the extension. But we can do even better: safe get or else. This generic extension checks if the list is not null, checks if the index is within bounds. If both conditions pass, it returns the item at that index. Otherwise, it returns a default value. This removes repetitive index checking logic and protects your app from crash-prone lookups. Let's wrap it up with another handy collection extension: map if not empty. This extension works on any list. If the list is not empty, it applies a transformation to each item and returns a new list. If the list is empty, it simply returns an empty list. It's a clean way to prevent unnecessary processing and keep your transformation logic focused. With one line, you express only map this if there's something to map. Let's talk about clean and idiomatic error handling in Kotlin, especially when working inside suspend functions. Before, we use multiple catch blocks to handle different exceptions like IO exception and a general exception. After, by using Kotlin's run catching, we cleanly wrap the network call and handle outcomes in a functional, fluent style. .map lets us transform the result if the operation succeeds. .get or else lets us gracefully handle all exceptions in a single place. This approach eliminates nesting, simplifies exception management, and results in a more idiomatic Kotlin structure. Here's another great example: refactoring a manual if-based flow into a clean and expressive Kotlin pattern using result and run catching. Original version: we first check if the JSON string retrieved from preferences is empty. If it is, we return an error. If not, we proceed to parse it using JSON. Improved version using run catching and result weather info. Wrap the entire logic in run catching to catch exceptions during deserialization. Use take if to ensure the string isn't empty before attempting to parse. Return a result, enabling the caller to handle outcomes cleanly with .onSuccess, .onFailure, or get or else. Let's walk through a powerful Kotlin refactor, cleaning up form validation using a fun interface, expressive logging, and the new context receivers introduced in Kotlin 2.20. We start by defining a validator interface to encapsulate the validation logic for fields like email and password. Then, inside validate signup form, we check each field and log the corresponding messages. This approach works well, but it requires explicitly passing form data and logger as parameters to the function, which adds noise and tightens the coupling between logic and dependencies. Now here's where context receivers shine. By leveraging Kotlin's new context receiver feature, we can implicitly inject dependencies like form data and logger. Inside the function, both form data and logger are accessible without needing to pass them explicitly. The result? A cleaner function signature with no redundant parameters, better separation between logic and dependency injection. This is Kotlin's modern approach to context-driven design. Now it's time to dive into some powerful Android-specific Kotlin extensions, the kind that can simplify your day-to-day app development, especially in domains like e-commerce, finance, travel, or any global-facing product. When building Android apps, you often need to display prices in the user's local currency, support different locales, show currency values with or without symbols. It's an extension on any numeric type, int, float, or double, that formats the number as a proper currency string. You can format it based on the device's default locale or a custom one you specify. Plus, it gives you the option to show or hide the currency symbol. Internally, it leverages number format, ensures 2 decimal places, and optionally cleans up the output for a smoother UI experience. Finally, let's look at Launch Safely, a coroutine helper for your view model. This extension simplifies launching coroutines within the view model scope, which is lifecycle aware and automatically cancels operations when the view model is cleared. Inside, it wraps your suspend function in run catching to catch and log any exceptions using log.e. This removes the need for repetitive try-catch blocks and ensures that failures don't get silently ignored. Here are some powerful and reusable Jetpack Compose modifier extension. Optional click. This extension allows you to conditionally add a click listener to a composable only if a valid onClick function is provided. If onClick is null, it simply returns the original modifier. If not, it applies the clickable modifier. This is perfect when elements should only be interactive under certain conditions. Apply if. A smart utility that conditionally applies a modifier block based on a Boolean flag. It takes a condition and a lambda block. If the condition is true, the modifier inside the block is applied. Otherwise, it's skipped. This is incredibly useful for applying padding, borders, animations, or click actions dynamically. Rounded background panel. This extension applies a rounded background with customizable corner radius and background color. Internally, it uses the background modifier along with rounded corner shape. It's great for styling cards, panels, or buttons with a consistent modern look. No ripple clickable. Use this when you want a clickable composable without the ripple effect. It uses clickable with indication equals null and a fresh mutable interaction source. Perfect for icons, overlays, or components where visual feedback isn't necessary, but touch interaction should still be captured. This extension controls visibility using alpha values. Based on a visible Boolean, it applies alpha 1f when true or alpha 0f when false. Internally, it chains the effect using then, allowing seamless inclusion in your existing modifier chain. A must-have when dealing with user input that triggers expensive operations or navigation. This extension prevents rapid repeated taps by introducing a debounce mechanism using a timestamp check. If a tap occurs within a defined delay, default 300 milliseconds, it's ignored, ensuring actions like API calls or screen navigation aren't triggered multiple times by accident. These small additions lead to big wins in maintainability and user experience. The shimmer effect function is a powerful Jetpack Compose modifier extension that adds a shimmering loading animation to UI components, commonly used for skeleton screens while content is loading. Internally, it uses Compose to ensure safe recomposition and sets up an infinite shimmer animation using Remember Infinite Transition. The core of the effect lies in animating a float value, shimmer translate, which simulates a continuous motion across the component. This value is then used to create a shifting brush.linear gradient using translucent shades of a given base color, producing a sweeping shimmer light effect. The gradient is efficiently drawn behind the UI element using onDrawBehind within drawWithCache, making it performant and frame optimized. The result is a smooth, reusable shimmer that adds a polished, modern touch to loading states. Next, we have 2 essential scrolling utilities, isScrolledToEnd and isAtTop, extensions on lazy list state that help you determine the current scroll position in a Jetpack Compose list. IsScrolledToEnd checks whether the user has reached the end of the list. It compares the index of the last visible item with the total number of items. This is especially useful for triggering pagination or showing a "you've reached the end" message. Is at top checks whether the list is scrolled all the way to the top. It returns true only when the first visible item index is 0 and there's no vertical scroll offset. This is ideal for hiding or showing UI elements, like headers or floating action buttons, based on scroll position. We all need a local data source at some point, whether it's to cache API responses, store computed values, or preserve lightweight user data. The cache KV class is a simple, reusable, and generic in-memory caching utility that stores key value pairs. Internally, it uses a mutable map of to hold the cached data. You can add items using put, retrieve them with get, and remove them using remove. There's also a clear method to wipe the entire cache, contain method to check for specific keys. This kind of utility is ideal when you want lightweight caching without external libraries or persistent storage. To make it even more powerful, the get or fetch function adds a smart, lazy fetching mechanism. It's a suspend extension on the cache class that first attempts to retrieve a value by key. If the value exists, it returns it immediately. Otherwise, it executes the provided fetch suspend function, like a network call or database query, then stores the result in the cache before returning it. This pattern is incredibly useful for optimizing data loading in real-world apps. It avoids unnecessary API hits and ensures your logic remains clean, light, reactive, and efficient. For example, the user repository class shows how to use get or fetch in practice. It depends on two components: user API service to fetch data from the network, a cache string user instance to store and retrieve results. Inside the getUser function, a unique key like user123 is generated based on the user ID. Then it calls cache.getOrFetch key. If the data is already cached, it returns instantly. If not, it fetches the data using api.getUserById user ID, caches it, and returns the result. So that wraps up this video. Hope you enjoyed it and learned something new. If you found it helpful, don't forget to like, share, and subscribe for more clean Kotlin tips and Android development insights. See you in the next one.